Did you know there's only one parabola? It's like a circle. You can make it bigger or smaller, but there's fundamentally only one mathematical shape that is a parabola. It has a focus deep inside, and if you ever see a shallow parabola with a focus relatively far away, what you're really seeing is just the bottom portion of the deeper parabola. So the focus itself is the same, only you're using just a smaller portion of it. You don't even have to use a symmetrical portion. You can use an off-axis hunk of it off to one side. If you use the focus, you can use this portion of the wall of the parabola. Apparently that's how these off-axis satellite dish TV dishes work. I was curious to see what goes on inside a parabola, so I rendered it using the Maxwell Renderer, and I made it so that the parabola itself is invisible to the camera, so you can see what's really going on inside. And it seems like it gets to be parallel rays right about here. If you look down the barrel of it, you can see this is what it looks like when you look straight down the parabola. One of the things that I was wondering is, why is it that the beam is confined to the center of the parabola? If the parabola is actually fairly open-mouthed, why is the beam so strong only here? And the reason it's kind of interesting is that normally when you see a graph of a parabola, you see the lines equally spaced going into the parabola and then converging at a focus. But if you put a light at the focal point and you have those light rays emanate in equal angles in all directions equally, like a point light source, when they hit the wall of the parabola, they will actually bounce away in such a way that they pile up in the center, exactly the effect that I got here.